Okay, I'm recording now. Okay, I'm recording now. So I'm recording. Okay, good. So today I'm going to talk about power factor. Yeah. So before I'm going to teach about power factor, let's review what we have learned during when we learn about power. Okay. So one important thing is power only dissipated at resistor. Still remember that? Power only dissipated at resistor. And the formula for calculating the average power is IRMS multiply VRMS. Okay? So power only dissipated as heat in resistor. Okay? Whereas for capacitor, there is no power loss. Yeah, average power is zero. Capacitor average power is zero. Yeah, it's because power is being absorbed and being returned to supply. Yeah, same thing goes to inductor. No power loss. The average power also zero. Okay, power absorbed and power returned to supply. Okay, so for both pure capacitor and inductor, the average power is zero. Okay, because no resistor in pure capacitor and inductor circuit, no resistor, so no heat is dissipated in pure capacitor and inductor. Okay, no heat is dissipated. So I did talk about that. Yeah, if you look at the graph of pure resistor, the average power is half peak power. Yeah, half P naught. But for capacitor and inductor, the average power is zero. You see, is zero because no heat dissipated at capacitor and inductor, but heat is dissipated at resistor. Okay, so only the resistor has average power. Okay, which is IRMS multiply VRMS R. Well, now now we're going to learn about power factor. No power is dissipated in capacitor or ideal inductor, but power is dissipated only in the resistance resistor. So in AC circuit, where there is a resistor, inductor, and capacitor, the total average power is equal to the power dissipated in resistor only. Okay, let me just explain in the one note. Yeah. That means what I means here is, okay, today we're going to learn about the power factor. Okay, before we talk about power factor, let us so we already learned about pure resistor, pure inductor, and pure capacitor. Now if let's say you have a RCL circuit, that means this circuit, it has all the components. You have a source, you have that means you have a resistor, capacitor, inductor circuit. Okay, so okay, I want the label first. So here you have voltage across the source. Here you have voltage across the resistor, voltage across capacitor, and voltage across inductor. Okay. Okay, let's say I want, just now he say about what? He say I want to find average power. Average power for this RLC circuit. What is the average power? Is the power dissipated in resistor only. So what it means here is okay, what it means here is to find the average power for this one, it is equal to power across resistor only. Understand? Because why? Actually, if power for capacitor and inductor, all of them are zero. Understand? All of them are zero. Because capacitor, inductor, no heat is dissipated, but only the resistor heat is dissipated. Only the resistor heat is dissipated. Got heat dissipated. But for capacitor, inductor, they can store energy and return energy. So no heat dissipated at capacitor, inductor. the energy only dissipated at resistor. Understand? So average power for the RCL circuit is only the power across resistor. Understand? So understand, class? You understand?
Yes.
Okay. So to calculate the average power across resistor, we just take IRMS. So remember, we learned yesterday in the yesterday video to calculate average power across the resistor, across pure resistor. We take IRMS multiply VRMS R. VRMS R. Okay. So IRMS multiply VRMS R actually. Okay. Only thing is yesterday one is a pure resistor circuit. So the actually the formula average power is IRMS VRMS R. But the thing is, this is a pure resistor circuit. So what you can see from here is this is voltage across a source, and this is voltage across a resistor. So what I mean here is this one can rewrite as IRMS. Okay, this thing can change to VRMS source. Understand? Because why? Because this circuit only has source and the resistor. So what I can say is V source equal to VR. You understand, class? You understand? This one, because this circuit only has resistor, so the V source is equal to VR. So this VRMSR can change to VRMS source directly. Or you also can write it as you can write it as I naught V naught source divide by 2. You understand this, right? Because I did show you that IRMS is I naught over cert 2, VRMS R is V naught R over cert 2. I did show you about this. So cert 2 multiplied cert 2, you get 2. Yeah. Okay. Anyway, what I want to say for pure, this is for pure resistor circuit. Pure resistor circuit. You can change the VRMS R become VRMS source. Because why? Because V source equal to VR. Okay. However, for this time, we are not using pure resistor circuit. We are using RCL circuit. RCL circuit, you cannot say this P average for this one is IRMS VRMS. I cannot say this is VRMS source. I cannot say this is VRMS source also. Understand? This one cannot. Do you know why?
Because dia ada selain daripada R.
Dia ada selain daripada R. Dia ada capacitor dan inductor. So for this one, do you know that for this one, VRMS source, how to get a VRMS source? VRMS source is actually not VRMS R. It is what? It is, you kena apa, Pythagoras theorem semua benda itu. Ada VRMS L tolak V. I don't want to put the word RMS lah. Okay, I rewrite the whole thing. I assume all these are RMS value. V source is equal, how to find V source? Is a VL minus VC lepas tu square plus VR square. Understand? For this case, the V source is not equal to VR. So we cannot change ini VR kepada V source. Tak boleh lah. Ini tak boleh lah for RCL circuit. For RCL circuit. Okay? Tak, dia V source bukan VR. So you tak boleh guna ini V source. Ini hanya VR saja. VR saja to calculate the P average because heat only dissipated at resistor, not dissipated at capacitor inductor. For previous one, pure resistor, yes, pure resistor you can change VRMSR to VRMS source because dia cuma ada resistor saja. So V source yang sama dengan VR. So you can change VR into V source. Understand? Untuk cari P average dia. Baiklah, kamu semua pandai ya. Kamu semua atau Zoo seorang saja. Okay. Sebab saya dengar hanya satu respon yang lain okey kah? Okay, so baik. Mari kita tengok terus seterusnya. So ini VRMS R, tak boleh VRMS source ingat. So it's just VRMS IRMS VRMS R saja. Okay, so we also can further change the formula, class. We can further change so ini memang tak boleh ini. So this one can further change to IRMS square R. Masa ingat kita belajar power equal to IV I square R ataupun V square over R. Masih ingat tak kelas? Dulu kita belajar ini. Same thing. So we can asalkan voltage-nya is for resistor, voltage for resistor, and this one use resistance, not the XC or XL but R. Okay, and then we also can change it to VRMS square. This is for VRMS R. Okay, and then this whole thing is okay, just drag a little bit down. Yeah, so this is for VRMS square over over R. So just make sure everything you use V for R, V for R, and then use resistor R. Okay, to calculate the average power because power across capacitor inductor is 0. Okay, class, don't use V source for this one because V source is not VR. Okay, V source is not VR. V source is this Pythagoras theorem. Okay, so that's for average power. Another thing is actually this term got wrong a little bit lah. This one is VRMS R actually. Yeah, this is VRMS R. VRMS R, so got wrong a bit. Now, another name for this average power, we have several names for average power. Okay, so average power can be also called what? Real power. Real power. It's real power or mean power. Sometimes we don't say average. We say mean. Mean, mean is average lah. Or we say real power, or power used, because it's power consumed lah. Power consumed. Because resistor heat dissipated means it consume power. For capacitor inductor, they don't consume power. They store the power and return the power. They don't use the power. Okay, power only used at resistor. Okay, understand, class? And then we also can say this is just limit into several names lah. I just want to tell all the several names. So it is also power dissipated. Power dissipated. Okay, power dissipated. Power dissipated lah, power or power loss. We can say power dissipated or power loss. Power loss in resistor only. Power don't loss in capacitor inductor because these two can store energy. These two can store energy. Can store energy. So power does not loss in capacitor inductor. Power only loss here. Yeah, power only loss here. lost and found. Okay, understand, class? So that's average power. Now another power you're going to learn is apparent power. Apparent power. Or we can say this is a power supply. Yeah, or power supplied by the source. Power supplied by the source. Okay, apparent power. So how to get apparent power? This apparent power is power by the source. Power by the source. So power by the V source, which is how to get this power? It is IRMS VRMS source lah. Power supplied. Understand? Power supplied by the source. Power supplied by the source is apparent power. Apparent power. Power by the source. So apparent is like not the real lah, not the real. If real power that really being used, power really being consumed, is only happen in resistor. But the apparent power is mean power supplied by the source is we use the voltage source lah. Understand? So power supplied by the source is actually definitely more than what power is lost. Okay, because power supplied by the source go to resistor, go to capacitor, go to inductor. But power that goes to capacitor, inductor are being stored in capacitor, inductor. They are being stored. Yeah, power supplied to the resistor is being lost. Okay, so the total power supplied by the source is the apparent power. So we use V source. Okay, understand lah, class?
Yes.
Good lah, yeah. All very good. All I consider all very good. So I square, if kalau V source kita setara dia dengan Z lah. Faham tak? Follow this formula. P equal to IV I square R. Sekarang ini V source, so ini guna Z lah. Kalau V source guna Z. Ataupun nak kira dia macam mana? V RMS source. Ini kuasa 2 kan, bagi Z. Faham tak? Okay? Tapi kan, kelas, tapi biasanya kita pakai apa? Kita pakai formula senang simple je lah. Kita pakai formula average power ini kita pakai apa? Ini I square R. Kita pakai ini. Okay? Kita jarang pula pakai yang lain. Kalau apparent power kan, if apparent power just take I RMS Z. We just take these two lah. Understand? Okay, so now power factor. Okay, power factor. What is power factor now? Power factor is real power over apparent power. Okay, so let me okay, can see so now I want to talk about power factor. So where should I write? Okay, so now I want to talk about power factor, or simple as PF. Still remember about power factor? It is actually cos phi, isn't it? What is the angle phi again? What is the angle phi? Angle phi. Okay, let's redraw. Where should I write? I think this one is a little bit up. Okay. Okay, what is angle phi again, class? You still remember what is angle phi? Let's say this one is a RCL circuit. Yeah. So this one is a RCL circuit. So that means okay, rotation anti-clockwise. Okay, so this is the current. Okay, where is the resistor, class? VR. VR is here in phase kan? And then we have what? I's and LE. Still remember that, class? I's, LE?
Yeah.
For capacitor, who is the boss? Who is the boss for capacitor? Current. Current is the boss. So current must be in front. So VC at the below lah kan? At the bottom. VC over here. VC over here. Where's VL? Where's VL? at the top here, yeah, at the top here, VL at the top here, yeah, because for L, the voltage is the boss, voltage at the boss, voltage leading current, yeah. For inductor, voltage leading the current. For capacitor, the current leads the voltage. Can you see that? Inductor, voltage leading current. For capacitor, current lead the voltage. Okay lah, you understand lah? Yeah, I consider you understand lah. Okay, got respond, no respond, I consider you understand. Yeah, yeah, but I don't know whether you listen or not. But I hope you listen lah. Okay, I hope lah. I always hope the best, right, for students. So this is the V source, correct or not, class?
Yeah.
This is the V source, and then okay, all the particulars. Finally, you get the V source. Okay, so this is the phi. I repeat what we have learned before. This is the phi, the phase angle, right? The phase angle. So from here we can say V source leads current by phi radian, okay. So do you remember what is this one again? So I also can read, you know, I can consider this one as, this one is XL, right, class? This one is XL, this one is XC. Remember that? I can consider this one as R, right? Correct, not, class?
Correct.
So V source is Z, correct? I can change the VL to XL, VC to XC, V source to Z. So VR is R. Okay. So from here you can see what is cos phi, power factor. Which is cos phi. So how to get cos phi, class? Cos phi is adjacent over hypotenuse. You can say it is VR over V source. Okay. Or you also can say it is R over Z. Correct or not, class?
Correct.
Cos phi, adjacent over hypotenuse. This one can either, you know, this one you can either put it as you want to put it as peak current or root mean square current. You can say it is V naught R over V naught source. Okay, or you want to put as what? You want to put as VRMS R over VRMS source. Also can, yeah, also can. So V naught R over V naught source, or VRMS R or VRMS over VRMS source also can. So either one lah, either one, yeah. When I write like this, VR over V source means it can have two, yeah. Can either use peak voltage or root mean square voltage. You use VR over V source or resistor over Z. That to find cos phi. Adjacent over hypotenuse. Okay. So now we learn power factor also. Now, okay. This one you put aside first. Okay. This cos phi power factor. Okay. This power factor. Okay. I want to continue talking about this power factor equal to cos phi. Actually, what is power factor? What is power factor? Power factor is the ratio, the fraction of real power over apparent power. The fraction. What is or we can say the real. Apparent means unreal lah. I can say apparent is like unreal. You know, apparent image. Real and unreal. Real over apparent. Or we can say it is actually power average over power apparent. Or we can say like this. How to yeah? Because real power is average power, what? Yeah, or mean power over apparent power. Okay. Anyway, I can say this is like real power is like power used. Apparent power is like power supplied. Now you can understand better, class? Can you understand better?
Yes.
That means not all power supplied by the source is being used. Only a fraction of it. Understand? So that means, let's say if the source provide 100% of energy, maybe only 20% of energy is being used. The other 80% of energy is distributed to capacitor, inductor. They are all stored and returned to the source. So no power loss. So only 20% of the energy supplied by the source is being used constantly in the resistor. So that means it's like, 20% of power is being used over the 100% supply. Only 20% lah. So it's like, it's not 20, it's like 20 over 100 lah. Yeah. So what is the power factor? Power factor for this one is 0.2. That means only 20%. Only 20% of energy is being used in the circuit. Yeah. Only 20% of energy is being used in the circuit in the resistor. Yeah. Over the 100% of energy supplied by the source, only 20% of energy is being used in the resistor. Okay, class, can you understand better now?
Yes.
So power factor is power used over the power supply. Yeah, or you can say just average power over apparent power lah. Yeah. So remember that power factor is average power over apparent power. How to calculate average power? How to calculate average power? I square R, isn't it? I square R. How to calculate apparent power? I square Z. Okay, let's put in the formula there. Let's put in the formula. So power factor, which is cos phi, it is average power is what? I RMS square R over I RMS square Z. If you cancel this, isn't it? Cos phi equal to R over Z. Da-da-da-dang. Yes. Cos phi equal to R over Z. Da-da-da-dang. Isn't it? Or you can also write it as or you can write it as VR over V source or V source. This one can either V naught or V RMS lah. This one you can either put V naught or V RMS. That's it, class. You see? All is related, right? If you really understand the whole thing. Okay, so I think that's all for yeah, I taught everything already, kan? Real power over apparent power. You see that? PR. So sometimes we put it as sometimes this power factor. We put the symbol for this. This is real power over apparent power. Yeah. That's why real power is PR. Real power is average power. Apparent power is PA. Apparent power. PA is not average power. PA is apparent power. So that's why I got a little bit confused here. Got average, got apparent. Both alphabet A. Both alphabet A. But PA actually refer to apparent, not the average. Yeah, it refer to apparent. PA is apparent power. Average power is PR, real power. Okay, class. Here, PR over PA. PA is apparent power. PR is real power or average power. VR over V. VR is what? VR is voltage across resistor. V is what? V is V source lah. If I don't write anything, this is V source lah. Understand? V source is I RMS Z. Can you see, class? V is actually V source. Yeah, V is V source. If no mention anything means it's V source. V source is I RMS Z. Okay, class.
Okay.
Okay, try to understand the notes. Try to understand the notes. This V is Vsauce lah. Apparent power use Vsauce. Okay. Apparent power use Vsauce. Vsauce. Mine actually is more detailed than the notes. You see that? And mine is more detailed. This V is what? V for Vsauce lah. V is Vsauce. You see? Vsauce. Apparent power is Vsauce. Mine is more detailed actually. Anyway, that's it for you got all the okay, finish already chapter 6. Now I'm going to continue with the tutorial questions. So that's it for power factor. Okay, I finished recording. Let me check. 1, 2, 3.